Well, hello, year 11. Welcome to your feedback session. Oh, sorry. For the homework, page 9 to 17. Same rule as always. Get your green pen. Make sure you have all the correct answer written down. Give yourself mark for the one you get right. Make sure you bring your exercise book, your book in class on the right day. Let's begin. Let's do it in less than 15 minutes. I'll attack. Okay, first question was about stem cells. Let me hide this. Here we go. So, um, cell change to become specialized for their job. All multicellular organisms contain stem cells. Stem cells are undifferentiated cells that can divide to produce more undifferentiated cells. These cells can differentiate into different types of specialized cell. Draw lines to match each type of stem cells on the left. Choose the description on the right. So you need to remember this. Embryonic stem cells come from the embryo. They can divide to produce cells that can develop into any type of specialized cell. The adult stem cell, on the other hand, can divide to produce cells that can develop into certain types of specialized cells only, not all of them. Write down one place in the human body where adult stem cells are found. There is a vast selection of possible answers. The bone marrow is the most famous. We can also have some near the liver, at the back of your eye, etc., etc. But the bone marrow is the most famous one. Write down one type of specialized cell that adult stem cells produce. Red blood cell and white blood cell, for example. Norbert takes a cutting from his best houseplant. A cutting is a small part of a plant that has been cut off, a stem with a few leaves. If a cutting is planted in some soil, it can grow into a whole new plant. Cutting must cutting must contain meristems. What type of cells are found in meristems? So meristems are other examples of stem cells found in plants. They can develop into cells which can turn into any specialized cell. Suggest how these cells help cutting grow into a whole new plant. They're able to divide and differentiate into all specialized cell types in a new plant. Okay, so if you think about the plant, there is a lot of different types of cells inside this plant. We remember the xylem, do you remember the root hair cell, etc., etc. The meristem cells can turn or specialize or differentiate into all these types of cells. Norbert's houseplants has red flowers. What color would you expect the flowers to be on the plant Norbert grows from the cutting? It would also be red, okay, because they're sharing the same DNA. Norbert took the cutting because it's cheaper than buying a new plant. So just one more reason why Norbert may have wanted to take a cutting rather than buy a new house plant. The plant grown from cutting will have exactly the same characteristic or identical characteristics to Norbert's original plant. So if he really likes his plant, he can grow something completely identical to it. Then a man has damaged the nerve cells in his spinal cord. The nerve cells carry information from the man's brain to the rest of his body. Fact. The damage means that the man can't walk. Scientists are investigating using stem cells to help repair the damage. True or false? Stem cells could be used instead of nerve cells in the man's spinal cord. False. Okay, you have to have a nerve cell in order to fix the spinal cord. Stem cell could be used to produce new nerve cells, which would replace the damaged cell in the man's spinal cord. That is true. And the stem cells could be used to stick the nerve cell in the man's spinal cord back together. No, that's not what the stem cells do. Okay, they can differentiate into specialized cells. Next, what type of stem cells would be the most useful for the man's treatment? Tick one box. The embryonic stem cells, because they can turn, they can specialize, they can differentiate into any types of cell. So that's the answer. Why might some people be against scientists using this type of stem cell to treat the man? So because they're coming from an embryo, remember, is made when by a fertilized cell dividing and dividing again. So they may consider that embryonic stem cells come from embryos, and some people feel that this shouldn't be used as each one is a potential human life. Why might scientists test the stem cells used in medical treatments to see if they contain viruses, so they prevent infection? Okay, the virus could be passed to the patient receiving the stem cells and make them sick. We don't want that to happen. Okay, next about diffusion. Diffusion is the movement of particles from an area where they are at a higher concentration to an area where they are at a lower concentration. Okay, very important. At the start, you have lots of particles in one side, none on the other. The particles are going to diffuse from the high concentration to the low concentration. Next, we have an example with squash here. The squash particles have moved from an area of high concentration, okay, the drop of orange squash, to an area of lower concentration, which is the water. The cup is refilled with cold water and the same volume of squash is added. Do you think the rate of diffusion would be faster, slower, or the same? It's going to be slower, and that is because the water is cold, therefore the particles are not moving as fast, so the rate of diffusion will be lower. Okay, the hotter things are, the faster the diffusion. Figure 3 shows two models of diffusion. Would you expect the molecule to diffuse faster in A or B? The answer is B, because you have a steeper concentration gradient. Okay, in A you have four molecules on the left, three on the right. That's almost the same, so it's slowly going to move. On B, you have four molecules on the left, only one on the right, so four times more. So the particles are going to move a lot faster from left to right. Madison was studying in her bedroom. Her dad was cooking curry for tea in the kitchen. Explain how Madison was able to smell the curry from the bedroom. Use the right keywords. So the curry particles diffuse from an area of higher concentration, the kitchen, to an area of lower concentration, the bedroom. After tasting the curry, Madison's dad added more curry powder. The smell of curry got stronger. Suggests why. There's a higher concentration of curry particles, so the rate of diffusion of curry particles increases. It smells stronger. Madison can smell the curry more strongly when it is hot than later on when it's cold. Why? That's because the higher temperature increases the rate of diffusion because particles are moving faster when they're hot. Practical. Arjun placed equal volumes of glucose solution and starch solution inside a bag designed to act like a cell membrane. He then put the bag into a beaker of water. So there's pure water outside and glucose and starch solution inside. After 20 minutes, Arjun tested the water outside of the bag. He found that there was glucose in it. How did the glucose got into the water? The glucose moved by diffusion from an area of higher concentration inside the bag to an area of lower concentration outside of the bag. Starch is a big molecule. Arjun didn't find any starch in the water outside the bag. Why? That's because the molecules are too big to fit through the tiny holes of the cell membrane bag. Arjun did the experiment again using the same volumes of glucose and starch solution. This time he used a much longer, thinner bag. Arjun found that the glucose moved into the water more quickly. Why? If you have a greater surface area and you have a smaller, thinner bag, the diffusion is going to happen faster because you have a smaller diffusion pathway and a higher surface area. Next is all about osmosis. Osmosis involves the movement of water molecules across a partially permeable membrane. Very important in the definition. What is meant by partially permeable membrane? It's a membrane that only lets small molecules pass through it. And which of the following statements about the movement of water molecule is true? Water molecules move both ways across the membrane, but the overall movement is to the more concentrated solution. Okay, so molecules go from left to right, right to left, but overall they move from the area of a high water potential, so almost pure water, to area of small water potential, the one where you have a lot of either glucose or salt, etc. Next, figure 1 shows a model cell in water. Would you expect water molecules to move into or out of the cell? The water molecules are going to move from the outside into the cell. Okay, there is a lot of water molecule outside. There's no sucrose. There's a higher concentration of sucrose inside the cell. Because the sucrose can't move by diffusion because it's too big, the water is going to move inside of the cell. If the cell stays in the water, it will get bigger because more particles of water are going to get in. Some parsnip chips were placed in solutions of different salt concentrations. All the data is provided here. By how many millimeter did the parsnip chip in the 0.25 mol per dm cube salt solution change in length? So at first it was 50 millimeter long. At the end it was 53. 53 minus 50 is 3 millimeter. Calculate the percentage change in length of the parsnip in that solution. To calculate the percentage change, you do the actual change, 3 millimeter, divided by the initial size, 50 millimeter, times 100, making sure you have the same units for all the values, and you should find 6%. State the concentration of salt solution that produced an anomalous result. It is probably going to be the 0.75. You can see the value keep on decreasing. They go from plus 10% to plus 6 to minus 2 to minus 8. So the plus 2 must be a mistake. Suggest the concentration of salt solution in which the change in the length of the parsnip chip would have been 0%. So that would be somewhere between 0.25 and 0.50. Okay, so you go from positive to negative change. Louisa was preparing some salted ham. She covered the ham in water and left it to soak for a few hours. When she returned, the ham was much bigger in size. The water molecules moved by osmosis from the pot into the ham. So the ham increased in size. Okay, you have a higher concentration of salt inside the ham than in the pot. So the salt cannot travel. The water can. So the water is going to move inside of the ham, making it bigger. Active transport. Um, so place a tick in the correct box to show the feature of each process in the table. Substances move from areas of high concentration to lower concentration, that is in diffusion, and the one that requires energy is active transport. Okay, diffusion happens without providing any energy. Active transport does require energy. Uh, Describe one way in which humans use active transport. So it's going to be used in your digestive system to move glucose from an area of lower concentration inside of the intestine or the gut to an area of higher concentration in the blood. That's mostly going to happen towards the end of digestion when your blood contains a lot of glucose. Figure 1 shows a specialized plant cell. Name the type of cell shown. This is a root hair cell, easily recognizable because of its shape and having no chloroplast. The passage below explains how this specialized cell absorbs mineral ions from the soil. Use words from the box to fill in the gaps. The concentration of mineral ions in the soil is lower than in the root hair cell. The cell uses active transport to move the mineral ions into the root hair cell. This requires energy from respiration. That means that all these root hair cells do contain quite a lot of mitochondria, so aerobic respiration can take place, and so the root hair cells are going to force the metal ions to go from the soil into the plant. Figure 2 shows a shorter version of the cell in Figure 1. Suggests why this cell won't be able to absorb mineral ions from the soil as quickly as the cell in Figure 1. It has a way lower surface area. So less things are going to be absorbed, less water and less mineral ions. Next one, exchanging substances. Organisms have to get some stuff into them and other stuff out. Organisms need to exchange substances with their environment. Multicellular organisms have specialized exchange surfaces in order to do this. These exchange surfaces are adapted for efficient exchange. For example, the surface of the small intestine is covered with villi. Give two ways in which these villi make the small intestine well adapted for absorbing nutrients. So they have a very high surface area, they have a very good blood supply, and have a very thin wall. Okay, so large surface area means they're in contact with a lot more, glucose or any nutrients. The good blood supply means that all the nutrients are going to be absorbed very quickly into the blood, and there's a very small distance that needs to be traveled by the nutrients to get into the blood. Next one, in humans, gas exchange happens in the alveoli. Figure 1 shows some healthier alveoli and some alveoli that have been damaged by smoking. Do not smoke, kids. The alveoli that have been damaged by smoking have a smaller surface area than the healthy alveoli. Fact. How will this affect the rate of oxygen? If you have a smaller surface area, less oxygen can be absorbed by diffusion. Okay, so the rate of oxygen diffusion will decrease. Figure 2 shows some alveoli with walls that have been made thicker through scarring. Suggest how the scarring will affect the rate of by which diffusion occur from the alveoli into the blood. The rate of oxygen diffusion will decrease, yes, because the thicker walls will increase the distance the oxygen has to diffuse. Okay, it's going to be a lot harder for the oxygen to travel from the blood to the alveoli. From the alveoli to the blood, if you have way thicker wall of the alveoli. In fish, gas exchange happens in the gills. Like alveoli, gills are adapted for gas exchange. Write down two similarities in the way gills and alveoli are adapted for gas exchange. Large surface area, very thin exchange surface, and good blood supply. Exactly the same. Next, I think this is the last question. Kwame did an experiment to investigate the effect of surface area to volume ratio on the rate of diffusion. So you put different signs of sugar, etc., etc. As the cubes get bigger, the surface area to volume ratio become smaller. Okay, you need to remember this calculation. As the surface area to volume ratio gets smaller, the time taken for the cubes to change color increases. Okay, it's going to take longer for the food coloring to get into the cube because it's further away from the surface. The longer the cube takes to change color, the more time it takes for the acid to diffuse to the center of the cube. The smaller surface area to volume ratio, the slower the rate of diffusion, and the rate of diffusion to cells deep in the body would be too slow for multicellular organisms to survive. Whoa, we made it in less than 15 minutes. See you next time, guys.